Hello students and welcome to the class. We have already studied about lot of thing about carbon, as we have studied about carbon, its nature and its allotropes. They stay in combined state as well as in free state. We have studied about covalent bonds. Now let me connect you. Why did we studied about covalent bond before we started carbon? So today we will finalize and we'll give a touch up why did we study it earlier. Okay, so let's start the class with some videos which will link you to carbon and its nature and the way they form bonds more. Okay, let's watch it. So students, let's start the versatile nature of carbon. See students, we already have gone through that how many things we use contain carbon. In fact, our cells are made up of carbon compounds. The number of carbon compounds formulae are recently estimated to be about 3 millions. That we already know and we have studied about it.
The structure of the covalent bond enables carbon to form a large number of compounds. Two factors noticed in the case of carbon. Carbon has the unique ability to form bonds with other atoms of carbon, giving rise to large molecules. This property is called catenation. These compounds may have long chains of carbon, branched chains of carbon, or arranged in rings. In addition, carbon atoms may be linked by single, double, or triple bonds. The carbon-carbon bonds is very strong and hence stable. This gives a large number of compounds with many carbon atoms linked to each other. Carbon compounds are linked by single bonds between the carbon atoms are called saturated compounds. Compounds of carbon having double or triple bonds between their carbon atoms are called unsaturated compounds. Since carbon has a valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of oxygen, hydrogen, nitrogen, sulfur, chloride, and many other elements, giving rise to compounds. The reason for the formation of strong bonds by carbon is its small size. This enables the nucleus to hold on to the shared pairs of electrons strongly. The bonds formed by the elements having larger atoms are much weaker.
Students, in this video we will understand how the carbon can form single, double and triple bonds.
With other atoms? Is it a single or a double or even a triple covalent bond? How does the bond formation by carbon take place? Let us answer all the queries related to bond formation by carbon in this video. Let's begin with understanding the simple structure of a carbon atom first. As we know, it has 4 valence electrons. That means sharing of all 4 electrons is possible. Thus, the valency of carbon is the most important factor for its amazing capacity to form bonds. So if we have a monovalent element like hydrogen, how will the bond formation take place? Wait a second, what do we mean by monovalent? We know monos is 1 and valent here refers to valency. That means elements having the valency 1. It needs 1 electron for stability. Coming back to our discussion, how will the bond be formed? This single carbon atom can share its 4 valence electrons with 4 different hydrogen atoms. It makes sure that each hydrogen atom attains stability by having 2 electrons in its shell, and even carbon gets 8 electrons in the outermost shell. How? 1 electron from each hydrogen atom makes 4, and there are already 4 valence electrons with carbon. These sum up to attain the octet state. This is how a methane molecule is formed. A single carbon atom bonded with 4 hydrogen atoms. Each bond here is a single covalent bond. This is how single covalent bond formation between carbon and any monovalent element takes place. Now let's talk about the double and the triple covalent bonds formed by carbon. To understand this, we take a simple example of the compound carbon dioxide. Can you draw the typical molecular structure of carbon dioxide? Yes, it appears somewhat like this. 2 oxygen atoms bonded with 1 carbon atom. How is this bond formed, by the way? We know that the valency of oxygen is 2 while that of carbon is 4. That means out of the 4 valence electrons, 2 electrons will be shared with 1 oxygen atom while the remaining 2 with the second oxygen atom. But sharing means both the atoms will participate in the bond formation, right? That is why at the same time, each oxygen atom also shares 2 electrons with carbon atom. Such type of sharing enables the atoms to attain stability. Wait a second. Did you notice that there are 4 electrons of a triple covalent interaction of carbon? Have you ever come across the compound hydrogen cyanide? Yes, it's an extremely poisonous liquid used for experiments in laboratories. Do you know what its chemical composition is? It's HCN. So do you know what the structure looks like? It looks like this. Yes, 1 carbon atom attached to 1 hydrogen atom and 1 nitrogen atom. Now, if you notice, the valency of hydrogen is 1. That means 1 electron of carbon is shared with this hydrogen atom. Moving to the other side, the electronic configuration of nitrogen is 2, 5. That means it needs 3 electrons to complete its octet, right? And we have the carbon atom waiting to share its 3 electrons. But we know that sharing involves electrons from both the atoms. That is the reason why even nitrogen contributes 3 electrons for participating in the bond formation. Remember, a covalent bond always requires sharing of electrons. So that is how 6 electrons are shared between these 2 atoms. Thus, 3 pairs of electrons gives rise to a triple covalent bond between the carbon and nitrogen atoms. Now, this was how carbon forms various covalent bonds with other elements. Is this the reason why carbon forms so many compounds? Well, this is definitely one of the major reasons why carbon compounds are widely found. So what could be another reason? One extremely important property of carbon is to form bonds with itself. Yes, a single carbon atom can form multiple bonds with other carbon atoms to give rise to massive carbon chains. This property is called catenation. Let's understand the property of catenation in the upcoming
See,
video.
students, carbon can form chain structures. Okay, this is a chain. Why they can form chain? Because they can share electrons with bond to bond, 1 to 1, one electron to the other electrons. Why I'm doing this? 1, 2, 3, 4, right? Same way, 1, 2, 3, 4. So we have to join the lines 1, 2, 3, 4. Same way they can form branches also. See, this is the way how they can form branches. This likewise also they can form branches. Okay, students, we will study in detail, there are a lot of things upcoming. These are only introductions. So this was the one way and this was the second way. Third way, they can form rings, students. Due to their capability, they can form rings like 1, 2, 3, 4, right? So this carbon can join here and then 1 is here, this, okay, this 1, 2, so they can link up 1, 2, they can link up with other. So I am just summarizing with it. You can try and practice at home, right, students, so that you can make it well. Even I need to do a lot of practice when I was studying about it, and even when you're doing it, you need practice now even. Okay, you are never out of practice. You can see that house benzene ring is ready, and this is this is a closed chain. So carbon is capable of forming closed chain structure. So thank you, students. I hope I helped you in studying it. You practice and we'll see you in the other class. Bye bye. Take care.